So a common problem that we get when we are writing a program is how to put together our output so that it looks good. So let's say that we have something like this. We're going to make a program, and we're going to say equals. So we're going to ask the user for their name. Let me do it this way. Let's do something like this. We're going to ask for user name, ask for height of wall, ask for width of wall, and then let's say we're going to do a little program that's going to calculate how much paint you need for a wall, and ask for the square feet per gallon of paint, and then we'll ask for the number of coats of paint, and then we will calculate how many gallons are needed, and then display the results. Well, up till now, the way we would do this is, of course, we'd say name is equal to input, please enter your name. The height is equal to float, because we're going to be bringing this in as a number. Please enter height of wall in feet. Width, same sort of thing. Almost just copy and paste this. And then we'll ask them to enter square feet of gallon coverage of paint. Normally I put spaces between each one of these things, but just to compress it so we can see the entire program, I'll do it this way. And then coats is equal to, this one will be an integer because you usually don't do half a coat of paint. And then we do our calculations. So let's see. So if we have the height and width, we're going to say the area is equal to height times width. That gives us the area of the wall. And then we're going to say the gallons for one wall, one coat actually, is equal to the square feet per gallon times the number of square feet, which is the area. And sometimes what's useful to do is when you do calculations, just put a comment next to that and say what the units are, and that helps you. That helps you keep track of what your calculations are. So gallons for one coat, that would be gallons. After I multiply square feet per gallon times square feet, then I just get gallons. Oh, actually, maybe I did this wrong. So square feet per gallon. So really, this should be the area divided by the square feet per gallon. So that's one of the useful reasons to keep track of your units, because then you detect, oh, okay, so if it's, so if it covers, if 1 gallon covers X number of square feet, then you need to do it this way. And then we need to know the actual number of gallons is going to equal the gallons for 1 coat times the number of coats, and that also will be in gallons. And then display the results. Up to now we would have done it this way. Name, comma, needed for, and we might do something like this where we just have number of gallons needed for a wall that is height feet high and width feet wide is gallons. And then, then wide. And then we got width num coats. Yeah, so we're going to say if it's that high, that wide, with that number of coats is this many gallons. So we've got all these things that we're trying to put into this one string, and then we run this. And let's see, so if we have a wall that's 10 feet high and 30 feet wide, and let's say that it covers 50 square feet per gallon, I'm going to put 2 coats of paint on it, we need 12 gallons of paint for that wall. So there we have our nice little paint calculator for a wall. And you can see, Rob, the number of gallons needed for a wall that is 10 feet high and 30 feet wide with 2 coats is 12 gallons. And that doesn't work bad. But let's say we want to have a little more precision over how many decimal points we wanted. It would be nice to have some way of specifying this format a little bit more cleanly. So I'm going to copy this over and make another one. So I'm going to say string formatting demo 2.py, and we're going to have, and so let's take this code, copy it, by the way, if you hit Alt-Z, it'll wrap your text. So we have a really long statement here, so I'm just hitting Alt-Z and it's allowing it to wrap around. And we're going to use the %s format specifier to do this. And the way you can do that with %s is, rather than do it this way, we can do this. So this is, so what we do is we put %s is where we want to substitute things in. So I'm going to put a %s here. I'm going to put a %s here. So I'm just putting %s's where I want things to substitute in. And then, so this is all just one string. It's coloring %s differently because it's a format specifier, but really this is now just one, rather than multiple broken up strings separated by commas. This is just one big string. And then what I'm doing is I'm going to list the things I'm going to substitute in the order that I have them here. So name, height, width. Let me see if I can get this to, there we go. Name, height, width, numcoats, gallons. And then I can get rid of, I'll just comment that out. So let's see if that works. Might need to make one change. And okay, there's one other thing that we need to do is here we put %, and then we put all of these things in a list. So this, we have this tuple here, we have a % sign here, and what will happen is this name will go into this first %s, this height, this %s, with this %s. This numcoats will go in this %s, and gallons will go in this %s. So basically everything, these are format specifiers, and they will take each value in this sequence that comes after this %. So this % is actually an operator that goes between a string and a sequence that can be used to dump things in. So let's give this a try. And let's see, let's make it 25. Number of coats granted is 2. And now we can see that this in fact works. So Rob, number of gallons you need for wall. So you see the name Rob got substituted in for this %s. Height, which was 10, got put in here. And notice that it displayed as 10.0. So that's one here. The width went in for this next one, 30. 25 went in for this next one. Oh wait, actually the next one was numcoats. So number of coats was 2, so that went in here. And then gallons went in for this last one. So basically the order you put these in is the order that they fill in the %s's. So that's one approach. The other thing you can do with this is if you have numbers, you can, rather than putting a %s which says render that as a string, you can use an f. And so let's see, name is going to be, should be a string. Height, what we can do is put %, actually we could put, well actually, yeah, we could put this, let's say we want this to be a floating point number, and we're going to say 0.2f. And then this one, the next one is also going to be a 0.2f. And then coats will be a D for decimal. And then gallons will also be a 0.2f. And then let's run that. And now notice what happened. When we put 0.2f instead of s, we got 2 decimal points of precision. So you can, if we wanted to be really super precise, we could change those to 0.4 or whatever, and we get 4 decimal points of precision. So we can change the precision we display. And when we put D, we just got integers displayed. And the %s just rendered as a number. So you can use these format specifiers with this approach to really control how things are displayed. And sometimes the way we do this is actually we'll break this up. And so what we might do is something like this. We might say format is equal to, and we'll make it equal to this string. And then we'll use the variable here. And if you run this, remember, a variable can be substituted in for the literal, and it will work just fine in a command. And so that worked. And then you could also say data is equal to, and we'll take this tuple out and assign it in here, and we will just put in data. And we'll run that. And you can see it still works. So one of the nice things about this is if you later on when we're doing loops, if you have multiple pieces of data you want to display, you could declare the format one time and use it multiple times with different sets of data. And this could be, let's change this to a list and see if this works. So now around the tuple, this is a list. Let's see, not enough for the format string. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, so this have to be a tuple. Yep. So you do have to make it a tuple for this to work. So let's look at another approach. So this is an older approach to how we can do this kind of formatting. A more recent approach is to use this approach. So I'm going to create a new demo. We're going to call it string formatting demo 3.py. And again, we'll take our previous code and we'll place it in here. And we could do it like this. So rather than using percents, we will use curly braces. And rather than a percent, you put dot format, and you put in your arguments, which is in this case, data. So we're going to say, use this format and put this data in. And now what will happen is each of these elements will be placed where these curly braces is. We'll run this again. And we'll give it a try. Oh. Let's do this. Let's just take this in here. And so we have to put them listed in this way. And so we can see now this will in fact work. And what's happening is the first element in your format is %. So notice the differences. When we use the % approach, we put % and then data. When we use this approach, we put dot format, and then inside of its arguments, we list out all the arguments we want to go in there. Another way we can do this is actually we can put numbers in here. And notice they're zero based. And there won't be much differences here. We'll see why we might want to do that in a second. But that still works. Where this becomes useful, let's say we wanted to reuse a number. We could do this. And so now what I'm saying is, at the very end, put this first one in here as well. And so the nice thing about using numbers is you could specify which ones you want to use and put them back in. So now you can see that Rob shows up on the beginning and the end. And so by using the numbers, you can actually pick and choose where these go in there and have more control over where these values end up in your format string. But notice once again, we have our numbers defaulting to a default location. Let's say we wanted 2 decimal points of precision here. So the way we can handle that is we can place, okay, so this is a string, but this one is, we want that to be 0.2f. So we want that to be a decimal point. We want this in floating point format with 2 points of precision. We want the number of codes to be decimal, and then this one will be 0.2f, and then that's a string, so we'll leave that as it is. And then let's try that. And now we can see we can control the, so we're saying put in element 1 here, and but use 2 points of precision, and then we can see we get our 2 decimal points of precision. So that's how we can control the appearance of that using this newer style of format specification. There's another way we can use this, and I'm going to make another demo as well. And we'll copy this over, so this format is called using F strings, and I'm just going to put this in here because it's somewhat simpler. And we don't really need this. So in this case, what we do is we put an F in front of the string to say that this is a format string. And then we just put what we want in here. And so I want name here. And I want, let's see, this one was number of gallons needed for the wall. That is, this is height. And then this one was width. And then this one was numcoats. And then this one was gallons. And then this one was name again. So this is probably the simplest of all. And it's only valid Python 3.6 and on. And with F, and this is called F strings. And so you just put an F in front of the string, and then you, in curly braces, you just put the name of the variable you want to be substituted in. And this is probably the one you should use more often since it's kind of the newer version. But we have to teach you all of these versions so that since they can show up in your code. So let's see if that works. So we put Rob 10, 30, 25, 2. And yes, in fact, it works as well. Now, of course, again, if we wanted to control the format, we would put these things back in. And now we have control over the number of decimal places being shown. And this makes for a very nice, easy to understand and concise way of doing your format specification. But this only works in Python 3.6 and on. So you still need to know these older methods because they will be still used. Yeah, so the first way we saw is with comma separation. And that gives us very little control. The next thing we saw was with %s's, and that works with Python 2 and on. So this is a good methodology to know because it works in all Pythons. And so just keep that in mind at that one if you have to go back to an earlier version of Python. This one will always work. This one works as well, but really if you're going to be putting your curly braces in, then probably using it this way with the variable names makes a lot of sense. It's just more concise and quicker, but it only works with Python 3 on. Now, how do we do this if we wanted to, say, make a table? So let's make another one called string formatting table demo. And let's say that we have a couple lists of data. So let's say there's just multiple walls which we're working with, and so we'll say walls, wall heights is equal to one, so say 10, 12, and 8, and we'll say wall widths is equal to 30, 20, 60, and 25. And then, and we're just going to show areas. So and then we'll calculate these. Area 1 is equal to wall heights at 0 times wall widths at 0. So I'm going to start off with an empty string of areas, and I'm going to then just calculate out all these areas. And we'll say that people or customers is equal to Linda, Rob, and Yarny. And so what we're going to do is, set up our data and then display it as a table. And so we could do this maybe, like we could say print we'll display the height, the width, and then the area. Oh, and then customer. So we'll put customer at the front. And then we could say print, and then we would let's see, so customer at 0, and then height. I'm going to shorten these names a little bit. We don't need them to be that large. We're going to find actually later when we do loops, this can be done much more efficiently, but I do want to show how to use the width function. So we're going to show heights at 0, or heights index 0, widths index 0. So this, and then areas index 0. And then we'll do this 3 times for each row. Just increment this. And if you're thinking there's a lot of repetition here, there is. But we're going to fix that later when we go through loops. And so let's see what this looks like. try to show the whole thing. Let's see. This is a little off. This should be 0, this should be 1, this should be 2. This should be 1, this should be 2, this should be 1. This should be 2. And let's see. And this again. Okay, there we go. Customer height, width, area. There's the customer height. And okay, so we've got our information, but it's not great, right? Because everything's not lined up very well. Well, how can we fix that? Well, let's look at doing this with %s first. What we could do is we could actually do this. We could say format is equal to, and we could say %s, 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 %s. And actually, let's see. So customer should be a %s. The heights, it should be 0.2f. The width should be 0.2f. And then the area should be 0.2f. Percent 0.2f. And then what we could do is we can use that format, and we can use it with and so this now needs to become a tuple. So I'm making this into a tuple with and we'll see why in a second. So now what we're doing is we'll say, hey, take each element of these and put it into this format so that it will line up. Actually, unfortunately, yeah, this creates a problem because this is not numeric, so that won't work. Let's do this for now. Let's just put %s's. Here. And what you can do is you can specify how wide you want those to be. So let's put each one of these at 20 and see what that does. So what this is use 20 spaces to position this. And so I'm going to just do the top row first and see what happens. And now you can see this is separated by 20 spaces. And so now I'm just going to do that with each one of these and see what happens. So now what we're doing is we're saying, okay, I'm going to use the same format string for all of these. So now this ends up becoming a tuple with all the things I want. I'm using the % operator to feed each one of these into this format, which is the same for both. And so now what happens is, because I'm using the same format for the header row and the values I'm displaying, we can see they're all lined up. Still looks a little odd, because if you notice this one, well, okay, they're lined up, they are right justified, which is okay for these numbers, but for these names doesn't work. Well, what you can do is you can put a minus sign. So I'm going to put a minus sign there and run it. And what that minus is, left justified. So now the names are left justified and the numbers are here. This creates a lot of space here, and I don't really need that much space for these areas here. The names could require about 20, but I'm going to shorten that even. So I'm going to make this 15. I'm going to change these to 10. So notice that now to adjust my table, I just have to adjust one row. And now I've got a pretty decent looking table. So that's how we can use format specifiers to format the table. And if you wanted these numbers to be left justified, you could do that as well, just by putting a minus sign in front, and you'll see everything will flip over to be left justified. I usually by default tend to left justify my columns unless I really see a need to right justify them. And then that works pretty well. So there we go. We have some pretty well formatted things. Now let's say that we wanted to format these numbers as well. I could make another format that I'll call format num is equal to, and I'll start off with this, but what I'll do is I'll make this first one be a %s, and then this one I will put 0.2f and then put 0.2f. So now I'm saying make these take 10 spaces but be represented as numerics, and then here I will make these be the format for the numbers, and let's see what that gives us. So now we're using a numeric specification for the second row, and now we get those decimal points, and it doesn't look bad. I think for these, I'll say, I think I want those because they're the numbers. It kind of works better for all of these numeric columns to be right justified. Maybe I'll change that to 10 and shorten it up a little bit and see what that looks like. And we're a little bit off. So, once again, because this one was off. And, as you can see, what you do is you just keep playing around with the format and just keep running it until it looks like what you want. So that looks pretty good, I think. There could be some tweaking. But the section of your book in Chapter 3 goes over a lot more in detail of this. And what I encourage you to do is go through and work through these various examples and play around with them and just try to give yourself a problem and see if you can use the formatting, as they show here to format, a table or just a string or, whatever you want to do. Use those tools and experiment with it. So that is how we can use string formatting in Python. Thank you very much.